Hello everyone. Today we are going to discuss about one of the most important algorithms named RSA algorithm. So here we go. First of all, I'm going to discuss about cryptography. Cryptography is the practice and study of techniques for the secure communication that happens in the presence of third parties, and these third parties are referred to as the adversaries. So we can say that cryptography is constructing and analyzing various protocols that are going to prevent these third parties or some other persons or the public from reading the private messages of the organization. That means if a message is sent from person A to person B, then any other third party, C person or public cannot get that information. So various aspects are there in the information security that are referred to as the data confidentiality, data integrity, authentication, and non-repudiation. And these are mostly centralized to the modern cryptography techniques. Now, if I talk about crypt, that means hidden. And if I talk about suffix, that is graphy over here, that means writing. So there's a set of rule-based communications that takes place, making some kind of calculations that are referred to as the algorithms that are done so that we can convert the message so that it can be safely going from person A to person B. And that makes it quite hard to decode it. So these algorithms, these are used for the cryptographic key generation, the digital signing, verification, and these protect the data privacy, the web browsing on the internet, and protect all the kind of confidential transactions. Those could be the credit card transactions, the debit card transactions, etc. So as we can see in this picture, that is that it goes from the encrypted data to the decrypted data. Then there are some types of cryptography, that is the symmetric key cryptography, the hash functions are there, and asymmetric key cryptography is there. Now what happens in the symmetric one, this is also an encryption technique. There is a sender and a receiver, and they use just a single common key for encryption and decryption. These are quite faster and simpler techniques. But what happens that there is a problem in this, and that problem is that the sender and receiver somehow have to exchange the key. That key has to be exchanged in a very secure manner. And the most popular is the data encryption system, that is DES. Next we have is the hash functions. That means we are going to use a hash value, and that also with the fixed length. And that is calculated using the plain text that we have. And so that makes it quite impossible for the contents of those plain texts to be converted and recovered. So many operating systems, these are using these days all of these hash functions because these are quite secure. And yes, these are used for encryption of the passwords. The next we have is the asymmetric key cryptography. So what happens, a pair of keys is there that is used, public key and a private key. So public key, that is for the encryption, private key, that is for the decryption, and these both are different keys. So even if the public key is known by the receiver, it can only be decoded if the receiver has that particular private key. So both the keys, that is the public key and the private key, are necessary. Now we are going to talk about RSA. This algorithm is asymmetric cryptography algorithm because it uses both the public key and the private key. Now, this is by Rivest, Shamir, and Edliman, and this was given in the year 1978 that gave its name as RSA. Now, it's best known and public key encryption technique, and it uses quite large integers such as 1024 bits, and it is based on the exponentiation in a finite field over the integers modulo a prime. The plain text over here that is encrypted in the blocks, those could have the binary value lesser than some number such as n. And what happens, that security is mainly because of the cost of factoring of the larger numbers, and that makes it quite difficult to solve. Now if I talk about some history of RSA, as I told you that this was given by 3 people, and now we call it as the public key cryptography. That was given at the start of the decade by James H. Ellis because he couldn't find a way to implement his work, and that was expanded by his colleague, that was Clifford Cox, to now what we know as the RSA algorithm and the encryption. So this final piece of the puzzle is what we known as the Diffie-Hellman exchange key. So Malcolm J. Williamson, he was another co-worker. He figured out a scheme that allowed two parties to share an encryption key. And so even if the channel was being monitored by some kind of adversaries. Now Diffie and Hellman's ideas, these were missing on the one important aspect that could lead to the foundation of the public key into cryptography, and that was a one-way function that would be difficult to invert. So what happened, that was in 1977, this Ron DeWest, Eddie Shamir, and Leonard Edelman, so whose last names from the RSA acronym is formed. So these came up with the solution, and that was nearly after a year of laboring on this particular problem. Now, why do we use this? So this is the RSA algorithm. So it consists of this crypto system that is a suite of the cryptographic algorithms that are used for the specific security services or the purposes that enables this public key encryption, and this is used for the sensitive data. So for example, if there is a client for the example browser and he has to send his public key to the server and request for some kind of data, so that is then using the public key for the encryption and the private key for the decryption. So there's the sender that has the plain text that is in the form of some ASCII code, and what happens, using the RSA encipher, the design target is created, and using the communication channel in the form of the cipher text, the data is transferred to the RSA decipher, wherein using the decryption key, that is the private key, it is converted back into its plain text. So for the RSA cipher, we have used the encryption key, that is the public key, and on the decipher we have used the decryption key, private key, at the receiver's side. Now what are the features of RSA? These are mainly confidentiality. That means the information should go only to the person who is intended to go to, and only that person should get that, except anybody else should not get that. Integrity, that means even if the information has been modified in some kind of storage or transition between the sender and the receiver, it should not have been modified. If it gets modified, it will lead to the destruction of the data, loss of data, so that thing should not be there. Then is the non-repudiation, that means the creator or the sender of information, he cannot deny or his intention of sending that very information at the particular stage. He should not be able to deny that at a later stage. Then is authentication, that means the identities of the sender and the receiver, these should be confirmed. Next we have the keys, as I told you, the public key and the private key, and these are for the protection from some kind of unauthorized access. What do you mean by public key now? Now, public key is a cryptographic because it can be used by the person to encrypt the message, and that could be deciphered only by the intended recipient, that also at the receiver side, using the private key. This public key is known to everyone, actually everyone. Yeah. And it is used for encryption. That means we convert the plain text to the cipher text, as I showed you in that very picture. Though a public key is a large numerical value, it is used for the encryption of data. I'll be just telling you how in the next few slides. So in the asymmetric cryptography, that is using the public key, and the decryption using the private key. So what is private key? It is a secret key because it is only shared with the key's initiator. It's not there with everyone, unlike the public key. The secret keys, these are only shared with the keys generator, making it quite secure, and it is used for decryption. And a private key is an integral aspect of the bitcoins, the cryptocurrencies that we're using these days, the altcoins, and security helps us to protect the user from any kind of theft. So private key, that is created by you, that requires the certificate owner. When you request your certificate with the certificate signing request, that is CSR. So this is my message, hello. Using the encryption keys, it's converted into 514, because what happens that hello 2 raised to the power 5, because there are 5 words in hello, HELLO. So 2 raised to the power 5, mode 14, that gives me 4, that is the encrypted message that will go to the decrypted side, and over there it's vice versa. What happens that 11 mode 14, so that is converted back to 2.